Hi there, second chance of trying to get our head around the product rule for differentiation. So whenever you differentiate, the posh word for that is finding a derivative. Whenever you use the product rule, it's because we've got two things times by each other. You'll remember last time we talked about having this formula where y equals u, I usually write uv dash plus vu dash or something like that, where you basically have one function, you leave it alone, times by the differential of the other, plus the other function times by the other differential. So this assumes that originally, of course, you've got a function which is y equals u times two functions, u and v. So if we'll look at a few of these in a bit, then hopefully we're happy we can just make more progress. So sometimes, of course, we've seen that we're using the product rule. Sometimes we use the chain rule. So here's a little tester for you as a starter to see which one's which. So your job is to work out which one you would do for each. So just have a look at those first of all. Do you think it's a chain rule question or do you think it's a product rule question? Give you a few seconds. Might want to pause the video just to make sure you've got time. Okay then, so hopefully you've now sussed which one's which. This one you'll notice is just an exponential function. So the rule we're using there is the chain rule. And as a matter of interest, if you were to differentiate, I'll write it over here, dy by dx. If you were to do the first one, it would be 2e to the 2x. That's an easy one to do, but it is the chain rule you're using. I'm not sure if these come up all at the same time. Yeah, one at a time, so that's a chain rule. The second one, notice there's two things times by each other. So this is what we're going to practice today. This is the product rule. I won't bother doing it at the moment, but this is one that you need to know. That's a product rule. And the trick is you've got something times something else. But there you've got something times something else, but it's such an easy something first of all. You can just, well, you don't even really need to even do the product rule. It's just, or the chain rule even, it's just going to be a simple one. What have we written? This is a simple function, there you go. So dy by dx here, the e to the x, if I differentiate, it stays the same. So the answer is 2e to the x. No, it didn't even change, there you go. And y equals e to the x squared, well, this is a chain rule again. Notice what I'm going to do. I'm going to, when you differentiate e to the x squared, you end up with, you just pretend it's e to the x, so it's e to the x squared, but then you have to times by the differential of x squared, which is 2x. So in the same way really as that 2 came down to the front, this is the same really, but now 2x comes down to the front. And I personally would write it 2x e to the x squared. Notice if we had to differentiate again, then it would be a product rule. So a couple of questions for us then, not many, but a couple. The daily amount of carbon emissions, C, tons, T days after the scheme started may be modelled by this function. And it's, notice for a start, it's in C and T now. It's not Y and X, it's the letters are C and T. But notice that's the times. So really we've got two functions. We've got the first function which is u equals 40t, and my second function is v equals e to the minus 1 over 30t. So let's differentiate them. 40t becomes 40 if I differentiate. Notice I don't care about the fact that t is not x's and stuff. And v dash, well, it's what I was saying before, this minus a 30th comes to the front. And then it's e to the minus a 30th t. The power actually doesn't change. All you do is you differentiate the power. So now the rule says times that by that, times that by that. So what's it going to give me? It's going to give me dc by dt. Notice the letters, not dy by dx, it's dc by dt. And that equals 40t times that. I'm just trying to do that in one go. It's minus 40t over the 30. E to the minus a 30th of t, and although it's not very nice, there you go. And this one, so plus 40 lots of e to the minus a 30th of t. You could simplify that. You can certainly divide by, that kind of thing, and but essentially this is the answer. You could take out e to the minus a 30th of t as a common factor as well. Hence find this maximum daily amount. So it says there is a maximum. So that implies we know max when dc by dt equals 0. So all this little lot is equal to 0. This is why sometimes it's useful to take out this as a common factor. So I shall do it now. Take out that as a common factor. That will give me, well, in fact I'm going to take out 40. I'll pretend I didn't, those zeros are still there. And then this first one will be minus a 30th of t. So you've got t, 40 is gone, but the minus 30 hasn't. And this one, is that exactly right? That is exactly right. Equals 0. Now I think we've seen this trick before. Exponentials are never equal to 0. Not unless you add some numbers or take the numbers away. So this has got no solutions, as exponentials are not equal to 0. This one can be equal to 0. Effectively, if I move all that over there, I get a 30th of t equals 1. Or said a different way, t equals 30. Now, that if t equals 30 is when it happens, I can then substitute t equals 30 in here. So therefore, c equals 40 times 30 e to the minus a 30th times 30, which is interesting because that is really e to the minus 1. So I'm going to type that into my calculator. 40 times 30 times e to the minus 1. I'm not sure how they want this answer, so I shall type it in and then I'll simplify it afterwards. So as a decimal, it's horrible, 441. I suppose it's better, you could write it as well, over e, because it's e to the minus 1. I reckon that's 441.5 or something like that. I don't even know what the question's about. It's emissions, tons, and presumably 441 tons. So yeah, it was actually that, because it was 441.45. So they've rounded correctly. I've rounded to 1 dp. So they're both right. Now we've got an exam question here. It looks like an exam question anyway. So a curve C has this equation: y equals e to the 2x tan x, and it's definitely a product rule. You can see it's something times something else, and it says x is not equal to this. So that's really taking account of the fact that if you're not careful, tan x is undefined at 90 degrees, or as we know, that's not, tan of pi by 2, and you can't do, or I don't really know, there is no such thing as this because there's asymptotes at the graph there. So we can't do that, and this is really a posh way of writing that. So ignoring the asymptotes, it's really saying, I can write that u equals e to the 2x, u dash, getting good habits here, 2e to the 2x, v equals, well, what, that's tan x, and I'm not sure if you've been taught this yet, v dash equals, I'm just having a quick check to see if you've seen this before. Well, I just checked, actually, you did see this in chapter 9, exercise 9a I think it was, and the differential of tan x, luckily we've seen it before because we're using it now, is sec squared x. So really, I'm just timesing this by this, and we're timesing this by this, so easy enough. So divide by the x equals, this one first, e to the 2x sec squared x. You should remember that sec is 1 over cos, plus tan x, don't know why I've written it that order, 2e to the 2x. And you can take out common factors, and it's nice to take out common factors. It's easier to solve the equations when you set them equal to 0. So I'm going to write e to the 2x, and in brackets I get sec squared x plus 2 tan x. So they tell me tan x is minus 1. Now of course I can move that over straight away, that tan, and I can just go x equals the inverse tan of minus 1. And the inverse tan of minus 1 is, it's minus 45 degrees, or if you prefer, because we're in radians, it's minus pi by 4. And you really have to do this in radians because differentiation integration rules don't work for trig unless it's all in radians. So that's my answer that I'm going to use. There are presumably other solutions, but that answer will do. And if I put that in, well, this will be some number, but you'll notice this will be e to the minus 2 lots of pi by 4. But this will be sec squared of minus pi by 4 plus 2 times by the tan of minus pi by 4. And all I need is to say that one of these two things is 0, and then the whole thing is 0. I want to prove that it's equal to 0. Is it equal to 0? Question mark. And I think you'll find if you type that in, it works. Now remember, sec squared is really 1 over cos squared. So you're going to have to type in minus 1 over cos of pi by 4. And then the answer you get, you're going to have to square it. You're going to add on 2 lots of tan of minus pi by 4. And I think you'll find you get 0. I'll leave that to you to prove. Therefore, we've got a turning point. So because one of them is equal to 0, times this by it, therefore the whole thing is. I'll leave you to convince yourself that I'm right. Now it says find an equation of a tangent at the point x equals 0. Now let's go back to this. This is what dy by the x is equal to. To find the equation of a tangent, I need to put 0 into this thing. So if I do that, at x equals 0, I'm going to write dy by the x equals, it's e to the 2 times 0 sec squared of 0 plus 2 tan of 0. Now the one thing I know is that tan of 0 is 0, so that disappears. E to times 0, e to the 1, e to the 0, sorry, is 1. So I can ignore that, it's 1 times. So really it's sec squared of 0. So what he said is 1 over cos squared of 0. So I need to know what cos of 0 is. Cos of 0 is 1. So this is 1. When I square it, it's 1. When it's 1 over it, the whole thing is 1. So my gradient is 1. Therefore I've got y minus y1 equals m. Should remember this from last year. X minus x1. So the one thing I suppose I still need here is the fact that we need a y value. So we know x is 0, you see. We know that m is 1. So the only thing I need is a y value. So if I just put x is 0 into this, it's e to the 2 naughts of 0 times tan of 0. Well, the great thing is there, tan of 0 is 0. So anything times by 0 is still 0. Okay, so I can now go over here. Y minus nothing is m. What was that? M was 1. X minus nothing. I think that's fairly straightforward. Y equals x is my final answer. Well, x equals y I've written, same thing. So yes, I'm happy with that. Last question. I'm not sure how I'll be able to do it all. In fact, so perhaps we'll save this for next time. We've got this. You can clearly see u equals e to the 2x, but I might try and just start it. V equals 4x minus 5 cubed. So u dash is 2e to the 2x. V dash, remember the chain rule, bring the 3 down, drop a power. Then you times them by the differential of this, which is 4. So effectively 12 lots of 4x minus 5 squared. So dy by the x, I want the equation of the tangent, so I definitely want to differentiate it, equals these two, e to the 2x times by 12 lots of 4x minus 5 squared plus 2e to the 2x going the other diagonal times by 4x minus 5 cubed. So what can I take out as a common factor? Definitely 2e to the 2x, like that. This is 12, this is 2, but then I can also take out the 4x minus 5 all squared. And what have I got left? On this one I've got 6 plus, and this one I've got 4x minus 5. So that gives me 2e to the 2x, 4x minus 5 squared, and this can be simplified quite nicely to 4x plus 1. Now I'm not going to do any more on that. Obviously it wants us to find a tangent, so it's a good place to stop, and the rest of the question we should be able to just tidy up. You might need a bit of help on that at the start of the next lesson. So to the next lesson we'll try and get that answer they've got there, but we'll just finish off exercise 10B as well, and that looks to me as if that's a reasonable place to stop. Best of luck.